Hello friends. So today we are going to learn boundary fill algorithm. So basic introduction. In this PPT, we will cover following topics like definition of boundary fill algorithm, types of boundary fill algorithm, its significance in computer graphics, and various important things. So let's move on. First, what do you mean by boundary fill algorithm? So the boundary fill algorithm is a method used in computer graphics to fill a connected area with a specific color. It works by starting from a given pixel and then check its adjacent pixel. If the pixel color is same as the target color, it fills that pixel with the new color and continues to check its neighbors. This process repeats until all connected pixels of the target color are filled. Let's understand what it exactly means. Like suppose here, the first we have to fill the boundaries. Like any shape, any image we have to first fill the boundaries. So first all these boundaries are filled with green color. Now suppose we want to fill this pixel. These all are pixels. We want to fill this pixel. So we check its first boundary color. Uh, we want to fill this pixel with red color, and now boundary is filled with green color. So we check its adjacent. So this is seed point. We will understand what do you mean in later slide, what actually seed point is. uh, so we first fill this with red color. Now we check its adjacent color. This is its adjacent. This pixel is also its adjacent. So we check its adjacent and put all it adjacent in a stack. You know the principle of a stack. In a stack, last in first out. So we fill all of its adjacent in a stack, and then we pop a stack accordingly. So this is already filled with green color. These three are filled in stack, and suppose we give number. This is 1, this is 2, this is 3, and the third one is filled at the top of the stack. Now we check it's adjacent and not filled, then we fill it with same color. This pattern going on until all are filled. Now, what its importance in computer graphics? So the boundary fill algorithm is crucial in video graphical application, including rendering of 2D shapes and images. It enables developer to create visually appealing graphics by allowing for easy manipulation of color in connected area. It used in graphic design software, game development, and image editing tools, highlights its versatility and importance in visual communication. सो ये दिस स्लाइड इज बेसिकली यू कैन रीड क्या क्या इंपॉर्टेंस है। लाइक इसका गेम डेवलपमेंट में बहुत इंपॉर्टेंट है। लाइक जो भी आप इमेजेस देख रहे हैं, पिक्सल्स देख रहे हैं, तो ये कैसे सब वर्क कर रही है, बाउंड्री फिल एल्गोरिथम से वर्क कर रही है। नाउ की फीचर्स ऑफ बाउंड्री फिल एल्गोरिथम, एज आई सेड दैट इज सीड पॉइंट। तो अब सीड पॉइंट बेसिकली व्हाट डू मीन बाय सीड पॉइंट? सो दिस इज स्टार्टिंग पॉइंट। लाइक जहां से भी आर स्टार्टिंग, जहां से हम स्टार्ट कर रहे हैं कलर करना, तो उसको बोलते हैं सीड पॉइंट। बाउंड्री कंडीशन, like the algorithm stop when it reaches the edge of boundary. Like if you are filling a polygon, basically polygons क्या होते हैं, और जितने भी shapes रहते हैं, तो बाउंड्री ऑलरेडी फिल रहती है, अपन उसके इंटरनल पॉइंट्स को फिल करते हैं। ना इंटरनल पॉइंट्स क्या हुआ, अब तुमने जहां से स्टार्ट करा वो सेट पॉइंट हुआ। अब अपने को उसका एडजेसेंट फिल करना है। कब तक फिल करना है? जब तक अपन बाउंड्री तक नहीं पहुंच जाते। जहां बाउंड्री पहुंच गए वहां अपने को स्टॉप होना है। और रिकर्शन स्टैक जैसे एज आई एक्सप्लेन्ड कि फर्स्ट जो भी अपन रे रहते हैं अपने पास, जितने भी उसके एडिशन रहते हैं उनको स्टैक में डालते हैं, और फिर जो स्टैक का प्रिंसिपल पता है, लास्ट इन फर्स्ट आउट, उस अकॉर्डिंग अपन पॉप कर देते हैं। टाइप्स ऑफ बाउंड्री फिल एल्गोरिथम, हाँ देयर आर टू टाइप्स ऑफ बाउंड्री फिल, 4 कनेक्टेड बाउंड्री फिलिंग, 8 कनेक्टेड बाउंड्री फिलिंग। डिफरेंस कुछ नहीं है, लाइक प्रिंसिपल सब में सेम है। 4 कनेक्टेड बाउंड्री फिल्स में क्या होता है, अपन 4 एडजेसेंट चेक करते हैं। जैसे दिस इज अवर पिक्सल, सो वी चेक दिस इज इट्स एडजेसेंट, दिस इज इट्स एडजेसेंट, दिस इज इट्स एडजेसेंट, एंड दिस वन, and these 4 are not its adjacent. Similarly, in connected boundary filling, all 8 are its adjacent. Now, the main point is you have to learn the coordinates of these pixels. Like this is our point x comma y. So this adjacent, the right one adjacent, the coordinate of its x comma y plus 1. Because in coordinate geometry, if we draw x comma y coordinate, this is y axis, this is x axis. So in this direction, the x value y value is increasing. Like in this direction y value is increasing, and in this direction x value y value is decreasing. Similarly in this direction x value is increasing, and in above x value is decreasing. Same here in this direction y value is increasing, and in this direction y value is decreasing, and in above x value is decreasing, in downward side x value is increasing, and diagonally as you see. To implement let's see how to implement it. To implement the boundary fill algorithm, begin by selecting a starting pixel that matches the target color. Change this color to new fill color. Then recursively or iteratively check its neighboring pixel up, down, left, right, and apply the same color changing rule to each matching pixel until no more adjacent pixel of the target color remain. The algorithm can be implemented using a stack to manage pixel and pending color changes. So the working is similar. Like first we have given target color. Suppose we have given red color. Let's understand. This is one pixel. Okay. These all are boundary pixels. In short, I am explaining. Hmm. So now this is our seed point. We have to fill this. This is our target color. Target color is red, and we want to fill this pixel with red color. And so the initial point is this. Now it becomes our seed point, and from this we check boundary condition first. Uh, the boundaries is adjacent, and boundary color is filled with black. It is equal to target color, no. So fill it with red. Now similarly we check it's all adjacent. This one is adjacent. This one is adjacent. This one is adjacent. So we put first this adjacent in stack, or we can use recursive or iterative method also. Now according to stack we put it, and now we check is this color filled with our target color? No. But it's adjacent is filled with target color. So we fill it with again target color. Similarly, this one, and process going on until all are filled. So I hope you understand it. Let's move forward. Application. So what are its applications? So basically for developing graphical user interface in CAD, to game development, as I said, 2D game development. Nowadays 3D games are going on, but in previous time 2D games are developed by using, if you played Super Mario game, then that game is based on this algorithm. And now flood fill algorithm, while both boundary fill and flood fill algorithms are similar function, but their approaches are different. In boundary fill algorithm, restrict filling to the border defined by different color, making it efficient for scenarios with distinct edges. In contrast, the flood fill algorithm fill area based on connectivity, enabling it to cover large area regardless of color boundaries. Like in boundary fill algorithm, we fill inside boundary color, we fill the color of polygon but inside boundaries. But in flood fill algorithm we don't do this type of things. We fill regardless boundary also. So this is a key difference between flood fill and boundary fill. Optimization techniques. To enhance the performance of boundary fill algorithm, several optimization techniques can be employed. One commonly used method is to implement a stack based approach instead of recursion. As I said, in stack based, like we put all its adjacent in stack. Suppose this is our, wait a minute. I think this one is not working right now. These are our seed point. This is adjacent number 1, 2, 3, and 4. And these are boundary filled with black. So these adjacent are first stack. Let's draw a stack. 1, 2, 3, and 4. 1 is filled, its adjacent are 2, 3, 4. For let's fill 4. Then we check adjacent of 4. So these are boundary. Adjacent is this one. This adjacent is already filled. Let us name 5. Then 5 is come. Then we fill 5. In this way, fill all of its inner pixels except boundary. So now we are on our conclusion part. The boundary fill algorithm is a pivotal concept in computer graphics, enabling effective area filling within defined boundaries. Understanding its application methodology and compared advantage over other algorithm ensures the graphic designer and software developer can effectively utilize this powerful tool to create visualizing, engineering, engaging, and precious graphical representation. I hope you understand it. Now, whichever we reach our last slide. If you have any question, you can ask in comment section. Thank you.